This is 5.9, part 1. Operations with complex numbers is the topic. Just go ahead and write that down. This definition is already in your notes. To review, what is an imaginary number? When you see a square root of a negative number, you want to replace that negative number with an I out in front. Also, if you have an I squared, you replace that I squared with a -1 in the problem. Don't write this slide down. This is just a picture of graphing in a complex plane. So if you have the traditional x-axes and y-axes in complex numbers, they're replaced with a real axis and an imaginary axis. These examples I do want you to write down. So go ahead and draw a coordinate plane, but replace the y-axis with what we call the I-axis, or the imaginary axis, and then the x-axis with the real axis. And there are 4 coordinates that we're going to graph, A, B, C, and D. So go ahead and write those down. Point A will be the complex number 3 plus 5i. Part B will be the complex number -3i. Question C will be 2 minus 6i. And then question D, 4 plus I. And we're going to just graph them all on the same coordinate plane. So this will be 2, 4, 6, 8. And this would be again 2, 4, 6, 8. Those are your positives. And then -2, -4, -6, -8, -2, -4, -6, -8. Okay, let's go ahead and graph our first coordinate. 3 plus 5i, the green one. So the first number represents the direction you go on the real axis. Since it's a +3, we're going to go in the positive direction on the real axis. The second number in the complex plane is your imaginary, and we are also going into a positive direction. So when we graph this, we're going to go 3 units to the right, and then up 5 units on the imaginary. So the point for point A is 3 plus 5i. That's the point. I'm just going to go ahead and erase those dotted lines. So there's our point in the complex plane. We're going to move right 3 on the real axis and then up 5 on the imaginary axis. All right, let's do point B. Point B says -3i. If I rewrite that, I have a 0 for my real axis and then a -3 on my imaginary. So I'm going to go 0 on the real axis, and then I'll move down 3 units. So here is my point B, -3i. All right, let's graph C. Question C says it's complex numbers 2 minus 6i. So that's a +2. So we'll go right 2 on the real axis and then down 6. And there's my point C, 2, -6i. I'm going to go ahead and change this last one to a -4 plus I. So again, that's a -4 plus I. So we're on the real axis. We're going to go left 4 this time, and then up 1. And here is our point, D. Left 4, and then up 1. And that's how you can graph complex numbers on a complex plane. next thing, part of this is in your notes. Go ahead and write the example, absolute values with complex numbers. I just pulled this from the textbook. What we're going to focus on is just the picture, and then we'll do the problem together. Again, if you want to look in the book later, you're welcome to do so. So here's an example. We want to find the absolute value of this complex number 3 plus 4i. So we would graph this complex number. So we would moving 3 to the right and then up 4. And what we do is we take the distance and the distance between those two from the origin. So we would get 4 here and 3 there. And then we would square them, add them, and then square root it. So let's go down to this example here. Find the absolute value of 3 plus 5i. So all you really need to do is square, I should say a squared here, 3 squared plus 5 squared. So 3 squared is 9, 5 squared is 25, and now we square root it, and we get 34. So the absolute value of 3 plus 5i is the square root of 34. You can't reduce any farther than that because of that radical. Now we're going to move on to adding and subtracting complex numbers. So we have a few examples here. We want to go ahead and add negative 3 plus 5i, that's one complex number, to a second complex number, 7 minus 6i. So when we do these, we want to add like parts together. We want to add the real parts together and the imaginary parts together. So these are my reals. So I'm going to add negative 3 and 7 together. And then these are my imaginaries. 5i plus negative 6i. Now I'm going to combine like terms. Negative 3 plus 7 is 4, and then 5i minus 6i is negative 1i. So there is a new complex number. Here's a second example. This one I'd say you probably don't need to write down since it's very similar to the last one. I'm going to just go ahead and drop the parentheses this time and then combine like terms. Because I have a plus and a minus right there. And now I combine like terms. 6, oops, this should be not an I there. 6 minus 2 are like terms. And then 3i minus 4i. So 6 minus 2 is 4, and then 3i minus 4i is negative 1i. Now let's go down to question C. Question C, I would recommend that you write down. Students make mistakes on these, and here's where they make the mistake. I have two complex numbers and I'm subtracting them. And students forget that when you subtract with a complex number, you have to distribute that negative through. So the first complex number is still just negative 3 minus 8i. But now I'm going to distribute that negative through to the second parentheses, the second complex number. So this now becomes a negative 2 and then plus 9i. Now I'm just going to group my like terms together. I have my negative 2 minus 3, as like, and then negative 18i plus 9i as my like terms. Negative 3 minus 2 is negative 5. And then negative 8i plus 9i is 1i. All right, let's go down to question D. Go ahead and write that one down. Now notice before we can add these two complex numbers together, we need to distribute the 2i through the first parentheses and the 3 to the second parentheses. We distribute to both terms. So 2i times 5 is 10i, and then 2i times 6i is 12